To see how we make a truth table, let's start with an example where we want to make something for the negation of a basic conjunction P and Q. So we're going to start with two columns that will represent every combination of P and Q, along with one for the conjunction itself. So just like what we had before with the true, true, false, false, true, false, and true, false, 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 false. Where from there, when we have those pieces together, we can then expand that out with one more column to look at the negation, where when we take a negation, we are flipping the truth value of every statement. So since we're negating that whole thing, we're just going to flip all of the truth values for everything from the original conjunction. So when the conjunction was true, it becomes false. When it's false, it becomes true. And that turns the whole thing from true, false, false, false to false, true, true, true. So if we want to think about what this might sound like, we can think of those penguins that we just talked about, where we could get something like penguins can fly and penguins can swim is not true, which is a true statement. It falls, just like before, into that third row where we have that P is false and Q is true, and then we're negating the conjunction, but it's also kind of a clunky wording. Well, we'll get to better stuff with that later. And in general, if we describe something like this, something with these connectives and all of our pieces, and we end up with a statement that's always true, we get what's called a tautology. That's not a tautology in this case because it can be false, but it is kind of close. And on the other hand, we're not going to see it quite as much here, but if we have something that is always false, we get what is called a contradiction because the two pieces don't work together. And then from here, if we want to get something more complicated, if we want to talk about things with more options, more simple statements, P, Q, and R, then we need to add another column in that starter step, where because we are adding two options for each case from before, two more true or false choices, we end up with 8 potential choices for those arrangements. We have 4 ways for P to be true, 4 ways for it to be false, 2, 2, 2, 2, with Q, and then alternating for R. Technically speaking, you don't need to follow that exact pattern the way it's written up here, but at the very least, for the sake of consistency, it helps to keep that going in that way. And then, moreover, if you have 8 options and you don't keep that nice pattern, you're more likely to end up with something that's either redundant or to miss something that should be in there entirely. And to understand how we use this, let's take another example where we're going to be returning to, let's say, a musical context here to keep building how these things look. For this, we're given the statement, I am feeling glad and I am happy, or I have sunshine in a bag. And suppose I am not happy, I am feeling glad, and I have sunshine in a bag. Under these conditions is the compound statement true or false. So the first thing we're going to do is carefully set our notation for what we actually have here. We're going to say that P is the statement, I am feeling glad, Q is the statement, I am feeling happy, R is the statement, I have sunshine in a bag, and we know that in this case, P is supposed to be true, Q is supposed to be false, and R is also supposed to be true as given by what we have here, as given by the conditions that apparently I am feeling at the moment. I don't know, but it's Gorilla's lyrics, let's not think too deeply about it. So, if you want to make the truth table for this, it would be the statement P and Q along with or R, with those parentheses in there, where we would get, very carefully, all of our options for P, Q, and R in terms of those combinations. We have 8 possible combinations. Then we would make the truth table for the conjunction there, P and Q, which again is true when both P and Q are true, so that's only true in those first 2 cases, at least how that thing's arranged. And then we throw in the disjunction with R, so that throws in our extra parts, where this disjunction will be false when P and Q are false, as well as R. That is, when the 4th column for the conjunction is false, as well as when the 3rd column for R is false. And in this case, we are looking at a situation where P and R are both true, so Q is false, which in this case is enough to get a true statement as we have here. That would fall into the 3rd row, as it were. So this is how we can use it in a bit of a silly way. So let's also see how we can use it in more of an applied and meaningful way.